Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history, beyond our dreams and our sights. Life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless
Hello, everybody. How you doing? Welcome to SkyTour live stream. It is me, Mark Antonio, this guy in the little corner here. Daryl's got the night off. He's got things to do, and he said he could not join us tonight. So I will be taking over, and well, I don't know, maybe showing you some stuff. I kind of know what I'm doing, but you never know, right? I just want to say hello to everybody that's here so far. I want to say hi to Michael Galea, who was the first one. Hey, Mike. Star Voyagers with us. Tim F. JSCO is with us. Daisy and Zoe are going to be here for a while. They have an early appointment tomorrow, but hopefully we can show them a few things before they go. Tiffany Echo. Hiya, Tiffany. How are you and Mike doing? Let me know. And we have Sam S. with us. Nice to see you, Sam. Goblin's with us. Do W is with us. And that's the early crowd so far, and there's more beyond that are here as well. Like Random is with us. Hey, Random, how are you? And Sally Forth is here. Hello, how are you? And so tonight we're going to be looking with both telescopes. So we have this view we're looking at right here. This is the wide field system out in the Sonoran Desert. And then we have this telescope, which is the higher, the much higher focal length system, which is out in Benson, Arizona, 220 miles away from this one. So this is Orion. This is the Orion Nebula, as we see here. And this guy right here is the target at the moment. This is an often overlooked little gem in the Orion Nebula. It's called Messier 43, or D. Moraine's Nebula. And D. Moraine's is quite an interesting location. If you look up in the sky here, you can see that it's dark here in Benson, and obviously 200 miles away over here in the Sonoran Desert, out west of Phoenix by about 75 or so miles. It's dark here too. This is D. Moraine's Nebula here. You can see that little part. So this gives you an idea of the field size. Oh, there goes Starlink. Okay, so we have this field right here, and this is the whole field size of this particular telescope. It's about 3 full moons by 2 full moons tall, 3 full moons wide and 2 full moons tall. All right, and this telescope over here, on the other hand, is actually just less than a full moon in size. I'm sorry, it's a little bit, a little less than a full moon in size. So the full moon fills this view. Luckily, we don't have to worry about the moon right now because it's a new moon tonight. So, or close to it anyway. So we're going to be exploring the night sky as best we can here from these 2 observatories. And we're going to be going to the same object in both and showing you what that looks like from the 2 different telescope points of view. It won't be fuzzy like me. It's going to be much more focused. See, I'm kind of fuzzy right there. And that's only because I'm a fuzzy person. You know? So, that said, let's begin. Hey, Kurt, how you doing? And so now I am going to start an exposure right here. I'm going to go quickly first to the stellarium here and back out because I want to actually just show you what we're looking at. Okay, so you see now, this is a live view of the sky, in terms of what we're seeing. And it's kind of dark right now, so that means that it's become quite dark. And this is our view in this telescope. Now, you'll notice when you look at this, that it's upside down. Okay? You see the writing is upside down. Well, that's because this telescope is in this particular position. I arranged this now so it's exactly what the telescope sees. So that will help us figure out how to manage the directions. Our field rotator that we're going to have is the one that's going to take us and give us the ability to actually rotate the camera, everything. And we're going to put that in as well. And we'll be adding to this observatory, I believe, hopefully in the very near future. And I mentioned this the other night, we're going to add a spectroscope to the system, hopefully. So we'll be able to look, for instance, at this nebula and take a small slice of it and see every single component in the nebula in terms of what it's made of. We'll see the oxygen, we'll see the hydrogen, and you'll see it right there on the screen. Visually, you'll see these spikes because this is an emission nebula. It's giving off light rather than absorbing energy and making a dark line in a spectrum like we will have. DW, thanks, man. I'll see you soon. So I'm going to start the exposure here, and we'll make this an exposure of some length. I'm going to first start up our guider here, which is different from the guider in the other observatory. So first things first, we connect all of our equipment. Okay, so now we're connected. Now we take a exposure, which this is 2.5 seconds. I probably can do a little bit less than that. So I'm going to tell it to go down to a 1 second exposure and do it again. All right, and now let's see if we can select a guide star or stars. Oh, we're good. That's excellent. So now we are guiding. Okay, and with this guide star in place, we can come back here and let's do a 25-second shot of this. Right, so there's a 25-second shot that we're going to start, and there we go. our filter is the UHCS filter. You see it right down there. That UHCS filter is the one that is going to allow us to isolate and look at just the nebulae and not look at anything else. And so that's going to be great. So I'm going to now go into our live stack here. And within a few seconds, we should get our first image. Okay, there we go. All right, so there it is. I see that we need to do a focus run. I'm glad I looked at this. Guiding is doing well. So let me just take care of the focus right now. What happens is telescopes are temperature sensitive. So when the temperature changes, the focus changes, and we have to figure out what to do with that. So what I'll do now is I'm going to move the focus in one particular, I'll move it in an arbitrary direction. And this, I think, is going to probably do it for us. I'm going to just stop this for now. Okay, and reacquire, because as soon as I did that, there we go. So we can guide on this maybe. Okay. All right, so now what I'll do is go back to the 25-second exposure. Yeah, that's going to probably work fine. And I'll pop out of our low light mode and go into our live stack again. And this is the previous view. The new one that comes in will actually, you'll see how these are kind of soft focus. When this new one's come in, it's going to actually be quite nice. So I'm going to clear this. And you'll see within a second, you'll see this new one come in. All right. There we are, and the stars are more focused. To see that. Now, there's a little noise. You see that noise. That kind of looks rough. The temperature on the sensor down here, you can see right down there, is minus 14.8 Celsius. Our target's minus 20. Okay. So we're going to be stacking now. When the second one comes in, watch how much better the image gets instantly. Okay. So I don't know if you saw that, but we started to see more clarity come in right away. That's pretty cool. I'm going to color correct these first. There we go. The reason I did that, even though it looked like it was color corrected, is because the oxygen here, this is the blue, the teal color of doubly ionized oxygen. So 2 electrons are bounced off the atom, and when they come back in, together they give off a combined light that is teal in color, and so that's what we call doubly ionized oxygen, or O oxygen 3, Roman numeral 3. It's not O2 for double, because we're astronomers, we like to confuse you. O1, the base state, is the one where oxygen has all its electrons. Okay, and when it has all its electrons, well, then we end up calling that the base state, the first level, O1. Okay, the base state, right? O2 is singly ionized oxygen. O3 is doubly ionized. Now, that's how that works. It's not, that's why, for instance, when we talk about other atoms, it's the same process. But we'll get to that. All right, we had a satellite come zipping through. Actually, I took an image of this the other night, and it did the same thing. You see this dark dust? Look at that. This dark dust is absolutely incredible, and for me, that's where life begins. That's the stuff. That's the locations in the universe where life begins. This is not empty space here. Okay, this is actually an area of space that's actually full of dust, because this entire region inside of Orion is a molecular cloud. And we can actually see it better by looking at the other observatory. So when we come over here now, okay, we look here, this is like a blister on top of the molecular cloud, which is back here. Now, if we do, in this case, we are already guiding, I believe, but I'm going to make sure of that. Just do this one little jog. Okay, and it's going to search, it's going to find a guide star. And as soon as it does, we're going to start a 25-second exposure with this telescope. All right, we're doing 25 with the other and 25 with this. Okay, So here we go. Now we're starting at 25-second exposure here. In the middle here, you see the trapezium. Now with the wide field scope, okay, we can see those stars, and we have some focus here, I believe. So, but with the other telescope that has a much higher focal length, we come in and look. If we were to look at the trapezium in this, it's very obvious. So we've captured 9 images. You can see right here, 9 images. These 9 images are nice. We've had none that are rejected, so our guiding is going just swimmingly. I've been trying to work out the bugs. Our guider is over here, all right, and you can see that we're guiding very nicely on this bright star. We have this star we're guiding on, this star, that star, this star, and that one. We got 1, 2, 3, 4, 5. We have 6, 7 guide stars right now. So that's going to help us stay really, really in with good guiding. All right. So we have 10 images exposed here, but look at this object. Okay. Now the full field is this. You see, that's the full field right now. This scope. So we actually have a very, very high focal length field, and this dark dust is 1,500 light years away from us. I can enhance it with an unsharp mask. You'll watch now these pieces start to look sharper. Okay. I don't know if you can tell. I think I can make that more enhanced. Okay, so now you can see there's more detail in this right here. And so, again, we have the ionized hydrogen here with details within it right here that we see. And then we have this beautiful dark dust. Let me try something here. We'll do this because I'd like you to see this. I'm gonna zoom in on this right here and just bring this in. Okay, so now you can see this dark area. Now this is the universe live in real time. This is happening as we see it. Okay, you'll notice the satellite trail is almost gone. Now why is that? Because subsequent shots bring the data that's back here, like the dark nebula back here, overlays the satellite trail. The data from this pink region of ionized hydrogen overlays the satellite trail. And so over time, satellite trails will disappear. Okay? I can see that we're still not quite focused, but we can deal with that. But this is pretty. This is wonderful. This region here in the Orion Nebula has been known as the Bay. And that's because when you look at it, and I can show you better in the other telescope, when we come back to this telescope, and of course we color correct and correct the curves, all right, you can see now this looks like an inlet in a bay, right? But look at that. Isn't that gorgeous? That's just a beautiful, beautiful region now. If I pull this in, you'll see a little more detail on the outside. And if I back this one off, the black level, if I pull that back, right, you can start to see some of the dust out here. Look at that. So this is the region we're imaging up close in the other telescope. All right, let me do a zoom on our field here. And I got to tell you guys, it is really amazing to be able to have 2 telescopes and do 2 different views at the same time. And then they're 220 miles away from each other, and I'm 2,600 miles from both of them. So it sort of freaks me out. I have to pinch myself to ask myself if it's actually real. You know, I think I'm going to wake up from a coma or something. Well, again, you know. So very interesting. Now, if I were to pull this is the mid-level, and we're on the wide field scope now, as you can tell. If I pull this in, you can start to see there's more detail out here. And if I bring this guy, which is our dark level, if I start to darken the background space, you get to a certain magical point where you can start to see all the wisps and details in this beautiful, beautiful stellar nursery, powered by those 4 stars we talked about before, the trapezium in the middle. Outstanding. Yeah, it's like outstanding, you know. And we can take this all the way up to just before the peak to make it its darkest. And you can see the different colors. The dust you can see is not black, it's brown. Look at that. Now we come up toward the Running Man Nebula up here. The dust continues. And it's all over in here. It's all out in here too. You can see how it continues out here. This is all dark dust out here. You know. So back in our other view. Okay. And actually let me do a couple things first. Let me just isolate this and say the Great Nebula in Orion. Set that as our target in this image. Okay. And save this image with annotations. All right. So now this will be saved in the Orion directory, and it is. And then we can come back to the other one. All right, and we will save this one. But first I gotta make sure that it identifies it. And this will be De Moraine's Nebula. All right, and it's going to be probably, here it is right there. There's M43, De Moraine's Nebula. Actually, I'll call it that. All right, and then we'll make that the target name. All right, and we'll save that with the annotations. Now, where are these going? They're going up here. They're going to skytourlive.org. You can go there in about 30 seconds and download these images I'm taking. Okay, and we save them both like this with the processing done. Like this. So I'll save this now. We have 23 here. I'll save this right now. And now that's already up there as an astronomical FITS format. And now we'll save it as a PNG file, a PNG. And what do you get with the PNG? This is the exact file that's going up on our server. Okay, this right here. This is what you can go up there and grab right now if you want to. All right, there it is. That's up there for you to grab. It'll be up there. If it's not there now, it'll be there in about 30 seconds. All right. So both observatories ship data off to our server. Okay. All right. So we'll go and bring this back and dock up our beautiful histogram and get this available again. Here we are. And so now that's, again, that's a kind of a close-up, but if we zoom out, you'll see it doesn't go out much further. Okay, we've got quite the magnification on this, which is great. So you get to see them from two different perspectives, you know. We see them from this perspective here, which is the faraway perspective, and we see them from this perspective, close up. And you know, I don't know that there's anywhere else you can see this. There's nobody else doing this out there like this, you know. But look at all this. Look at all this beautiful dust. And if we were to go like this and pull our mid-level all the way up here, really exaggerate it. Yes, it blows this out, but look how much more dust we see. Look at this very faint wisp of reflection nebula up here. Isn't that beautiful? This looks blue, by the way, compared to the teal that we're looking at down here. They're subtly different. Okay. The reflection nebula, the blue nebula, this really blue nebula, like around the Pleiades and around much of the Running Man, this is actually just light that is reflected by dust grains that are these brown particles that are close to the stars and reflecting light. All right. So that said, we can see that these dust particles really like blue light, and they reflect blue light. And so that's what we see here. When they're in front of the nebula, well, then we see them as dark. But when they're behind and illuminated by the stars and such that we can see them, you might see them as a blue reflection nebula. But then down here, this material, this isn't a dust reflection. This is actually a atomic transition we're seeing. The nebula is caused by a glowing oxygen that is doubly ionized, and then the hydrogen that is singly ionized glows red. Interesting location. I'm going to show you this right here. This is something cool. This oxygen is very wispy and tenuous. Okay, so you notice you can see this red nebula through it. Do you see that? This is like a cloud overlaying the red nebula. So this bluish green oxygen ionized cloud is in front of this beautiful wisp of hydrogen. Isn't that amazing? And we can see that. We can see that very clearly. Hey, James Dugan. How are things down in Australia? Nice to see you. So yeah, this is just incredible. It's a really, really interesting location. And I think we might be getting a little wind out here. I'm going to unstack this last one. See if it makes a difference. No, okay. Actually, it did make a little difference. All right, but look at that. And of course, a Starlink satellite came through. Actually, that's not Starlink. That's a different satellite. And look what it's doing. It's slowly tumbling. See how it gets brighter for a bit, then dimmer, then brightens up again? That's a slowly rotating satellite or rocket body. Probably a rocket body that launched something, probably most likely to a geosynchronous orbit. Okay, let's do this. By pulling back just a little bit, we can get rid of some of the noise. Isn't that gorgeous? Oh, that's beautiful. We're going to save this. 20. And save exactly as seen. So in this case, this is the image you get when you go up to the server. And you can download that in about 30 seconds. Okay, so you go to skytourlive.org, scroll down, and you'll see Take Me to Cool Pictures, and you can go there and check it out. You know, really cool stuff. So, as I might have mentioned, but for the people that arrive a little bit later, Daryl's taking the night off. He's got things to do. So I'm going to take over and do this like I did way in the beginning. Except I'm not doing it from a freezing, frigid dome outside like I used to. I used to be in the dome doing it. Now I feel almost like I'm cheating, because now what I'm doing is I'm doing it from the comfort with a space heater down below here. It's chilly outside in the 40s, and I'm nice and warm in my little office. My office is made up to look like a battleship. I've got real portholes for windows because I do a lot of work for the Navy. So everything in here is Navy. Everything's Navy. You got I-beams for the ceilings. You got rust on the walls for various spots, because the Navy sailors are very bad at doing maintenance, you see. Maybe at some point I'll do a tour for you and show you the shop and everything, because my special effects shop is that way. Through the shipping area. And so this is cool. C&D boy, how are you? That's just stunning. I've missed this telescope. This telescope gives us really quick views. Look at the detail in these nebulae. Let's go back now and look at this one. All right, now you can see now this telescope gives us way more detail in Demarane's Nebula, M43. Here's the Orion Nebula, and you can see these beautiful borders of this gorgeous cloud. This is the oxygen, doubly ionized oxygen cloud, O3, and you can see how it's out there, and it's been shaped by stellar winds, and those stellar winds are probably the ones in the trapezium here. Okay, and the oxygen has moved further away from the trapezium than the hydrogen, because it's been whatever motion that it had when it was made by some supernova somewhere, that's continued potentially. And so these stars, though, they tend to make a cavity around themselves. This is a rather young nebula. So it's basically in the full throes of stellar formation, and using the James Webb Telescope, we could look in here and see thousands of stars, many of which are just forming in this region. So this is just beautiful. All right, let me we'll save this here again. All right, save exactly as seen. Okay. All right, so that's Messier 43. It's a beautiful location, and we can now go to the next item, the next object we want to look at in the sky. And I'm thinking that since we're in Orion, we should take off up north and check something out up there. And I hope that we can go check out another dark nebula that's right here. And then we'll ride up to the Casper the Friendly Ghost as well. Okay, this is the Horsehead Nebula right here. And this is Alnitak, the leftmost star in Orion's belt. So we're going to go hang out by Alnitak for a little while. Alright, and I will move that in with the other telescope as well. Yep, and of course the guider is complaining because, yes, I moved. Alright, yeah, of course it failed. Alright, so now let's do another guide star grab. And first of all, let's just make sure it's here. I can actually figure that out right now by doing this and doing this. I'm gonna guess it's nearby. Yeah, see, so we're not far off. Okay, so now this one we're gonna do a 35-second shot. And before we start it, I'm going to grab our guide stars. And what I'll do is I'm going to increase the exposure here to 1.5 seconds. And so now we have some stars in there. And let's see if we can grab some stars. There we go. Alright, let's guide on that. That's a beautiful star, actually. You can see this beautiful peak here. Alright, so that should stick around for a while. So now we can do this photo. We'll get out of low light mode and go into our live stack. Okay, see the telescope up there in the building out in Benson, aiming toward the southwest because Orion is past the meridian. This telescope over in here in the Wickenburg area out there is doing the same thing. We will take one more photo here, save exactly as seen, and while we're waiting for the other one to come in, we are going to do the same thing. We're going to go up to the Horsehead here as well, so you can see the difference once again. Let's go up here and get this. Interesting. Okay, it won't matter that much. Alright, so let's jump out of this. Telescope is going to move up a little bit, and we're going to... That's such a beautiful spot. That's the most beautiful nebula in the sky in the northern hemisphere anyway. No doubt about it. Alright. Oh, sorry. I didn't get out of the stack. My mistake. Okay. Alright, so right there. Okay. The Horsehead is right here. This is Sigma Orionis, responsible for lighting up this cloud. You can barely see. There's Alnitak right there, the beginning of the Flame Nebula. Alright, and I want to just make sure that we are guiding right now. So let me just jog us one drop to the west here. And now we'll make sure we're guiding. And we'll come back and make this a 25-second shot. Okay. So we can start doing this. It will start guiding anyway. And I'm going to go into our stack mode. And the first thing we're going to do is clear this. And dock it so that it's docked up. Okay, so we're guiding here, and meanwhile in our other shot, let's see if that's, oh, look at that. Now here in this shot, we see the Horsehead Nebula. All right, and this is gonna flesh out really beautifully. Let's check our guider, make sure it's doing well. Oh yes, guider's having a fun time. Look at that, huh? So we're gonna see more detail in here as we move forward, and over in the other telescope, okay, we already can see that we're gonna have to clear this and let this one come in again because it wasn't fully guiding the way we wanted. That's better. All right, that's that. So you see how much smaller it is, and what we're gonna do is we're gonna back the black level off a little bit and drop the white, this mid-level down to help mitigate noise a bit, and this will actually make it look a little better until it can support having those curves brought closer together. You need more frames for that to happen. But this is the overall view, right? And this is the full size of the view. Look at that. Okay, so that's 3 full moons across and 2 full moons tall, and there's the Flame Nebula. All right, and so there's value to these telescopes like this with a wide field like this, because you can see lots and lots of things all at once in the view. But then when you look at telescopes like this, there's the other value now of being able to see all kinds of structure and data in these close-up views, you know. Now I have the Horsehead down here. There's not much down here to see, so I got it kind of at the bottom, so you can see these are going to look like boiling clouds in a little bit when this actually comes in, and get a kind of a hint. We can overprocess briefly to show you what else is out there, and you can see that these clouds will be much more well defined in a little bit. Okay, so first thing we'll do is we're going to make a note of what we're looking at here. Okay, this is the Horsehead, and we're going to make that our target name, and we'll it's already centered in view, and then we'll save it with the annotations. Okay, so there we go. And now let's go to the other telescope out in Wickenburg in the Sonoran, and let's do the same thing here. As you can see, a lot more things show up. So we have the Horsehead Nebula right there, and we'll set that target name, and we'll save the image with the annotations. So that'll also be out there for us to show. If you want to look at it, you can grab it and see what's out there. Okay. Meanwhile, that's going to keep coming in. All right. And we'll do the Flame Nebula a little bit too with the other telescope, which is really pretty. Okay, so we'll let that one percolate a while. Let's come back here. Let's color correct and see if we can see what the color looks like with this camera. Yeah, it's really beautiful. Now you can see these wispy fans of red hydrogen gas that's starting to show up now. Okay, and you can see the clouds here, the billowing clouds of material. These clouds mixed with dust. They're showing up. This is a large dust cloud, a molecular cloud. And a molecular cloud is one that's actually a cloud made of molecules of carbon and silicon and other materials that were ejected in supernovae as well. Because once you eject this hot material from the stars, okay, they will form molecules out in space. And a lot of this dust is made in the outer atmospheres of these red supergiants. Betelgeuse, for instance, is one of these red supergiants. And Betelgeuse is, well, just up there from where we are, because remember, we're turned sideways. And so if we go back to Stellarium for just a second, all right, and we center up on the Horsehead Nebula here, you can see where we're looking, okay? Betelgeuse is up here, and that's pretty interesting. Now, these 3 belt stars, just so I can tell you quickly, these are all O-type stars, the hottest and bluest there are. Okay, this one, similar, Bellatrix, very hot. Betelgeuse, and well, and Rigel down the lower right is very much the same. Betelgeuse used to be one of these. Betelgeuse was a hot blue star, okay, like this. But these are young. These are only a few million years old. Like Alatak might only be about 4 million years old. And it's not going to last another 4 million years. Within that time, it may very well go supernova. So the belt of Orion is a transient phenomena in the grand scheme of the universe. Betelgeuse, the shape of Orion, Orion the Hunter, which ancient peoples from thousands of years ago have seen forever, okay, is transient. It's a transient phenomena. It's going to go away. Now, what's going to end up happening is that Betelgeuse is going to go supernova, probably before any of these. And when that happens, we'll see that star in our daytime or nighttime sky. In the daytime sky, yes. Because it's going to be so bright that, like the Crab Nebula, Messier 1 in Taurus, the Crab Nebula was visible in 1054 AD, and Chinese astronomers saw it, logged it, cataloged it, and said, wow, that's something. What is that? It's a new star in the sky. And it was. It was a new star. So that said, this is something that is very much, very much something that is going to happen to all the stars in Orion, you know. So when Orion finally ends up reshaping its face, we'll never recognize this constellation again. What we will see are many bright nebulae in here, because after they go supernova, they're going to give off all this material, and they're going to cause it to glow like this hydrogen is, and it's going to cause all kinds of things to glow, and that's going to be incredible. And there's going to be the hot ultraviolet radiation from that explosion that causes this to happen. Hey Kevin, how are you? Nice to see you. Kevin O'Neill is with us. Daryl has a night off, Kevin, so it's just me tonight. Jessica S is with us. How are you? And let's go back over here now and look at our view from the Sonoran scope. As you can see, it's coming in nicely. If we zoom in on the Horsehead, you'll see that it's a little bit fuzzier than the one we were working on. I see we're a little out of focus on this one too, but we're going to fix that as well. Okay. Yeah. Neat. All right. So we'll fix that as well. Again, the temperature now out there is 22 Celsius. It was very hot actually out there. I think it was up to 90 in North Phoenix today. What I wouldn't give for that, you know. Anyway, these you can see these stars are embedded in this nebula, and as you can see, we're seeing reflection nebula. This blue color. This blue color is due to the dust grains, as I mentioned, that are reflecting back the blue light. They love blue light, short wavelength blue light. They love it, and they take it in and they throw it out in all directions. Well, our atmosphere does that too, to the sunlight coming in, and that's why we have blue sky. So this blue you see right here is there for the same reason that we have blue sky. Dust, in our case, atmospheric molecules, are scattering the blue light from the star that's there. And it doesn't scatter the red light or the yellow light, okay? It only scatters the blue light, because that's a very high energy, short wavelength. That's the stuff that scatters very nicely with these particular dust grains. It has to do with the size of the dust grain and so forth. Okay, so this is beautiful. There's a little tongue of a dark nebula that's sticking in, and it's in front of the brighter nebula behind, so it's silhouetted by the brightness behind it, which is kind of cool. All right, so that's that one. So it looks pretty neat. Alnatok has a halo around it because of our optical system. All right, And if we look back at this other one, all right, the horse head, this is coming in nicely. We can see the stars inside the horse head very nicely. And we can, if I were to push this, okay, you can start to see how this billowing cloud is starting to develop. Very pretty. I'm gonna take off this sharpening so we can actually soften it up a little bit. Karen Belmont says, came in for a quick tour, huh? Oh, came in from quick tour over semi-cloudy Minnesota. The two Canis major and minor and the two bears, Ursa major and Ursa minor, out there. Orion setting and Jupiter, a few lovely bright stars. Oh, that's very nice. Hey Toner, what's happening? All right, yeah. Okay, so let's save this. We've got 20 here, and we'll save that exactly as seen. So now you can get the ping file, the one you can just open it up and check it out. And then over in the other one, we'll do the same thing over here. All right, we have 16 done over here. We'll save this as well. And save it exactly as seen. All right. So there's the horse head. So now I think what we'll do before we lose it is I'd like to go to another object to show you, because we haven't seen it that much, but it's really pretty. And it's not just pretty, it's very instructional to see it. And we'll do that. Let's go there. Hopefully we can get to it and it's not too low. It is higher in the sky. Yeah, it's actually higher than Orion right now. So let's go look at it. It's up here. And it's right... I gotta get a little closer. Let me... first of all, there we are. It's right there. That's the Crab Nebula. It is the quintessential supernova remnant. So we're going to go there with this telescope. Watch it here. It's going to end up going a little higher and probably stay just about the same. And we'll see a fuzzy object start to show up in here. There it is. Okay. We'll get that to come down here. All right, and we're going to refocus too while I'm here. And so this is interesting because this one is one that shows us a lot of detail in a supernova. This is a star that blew itself to pieces, and it's going to show us a lot of interesting filamentary structure. And it's possible that the filamentary structure has been created by, hi Izabela, has been created by electrical currents running through the filaments. Now, it's a tenuous electrical charge, but it's something that is, it's something that is very, very likely going on inside here. Okay, I'm going to get a refocusing done here. So there we go. And we're going to start focusing, get a critical focus here because we need that for this particular nebula. And meanwhile, we're going to go over to the other one in here. And as you can see, we got that beautiful nebula. We're going to save one more time here with 25 taken here. Okay, save exactly as seen. And we're going to come out of this. And we're going to go back to our low light mode. And we're going to take a ride over to the Crab Nebula here as well, because the Crab Nebula in this telescope is really, really something, and we have to see it. Right there. So here we go. And our guider is no longer guiding, obviously, because I did that. All right. And it's right there. You can see it very, very faintly, but it's there. Okay. So let's get our guide star and get our guiding set up here. All right. And we got a 1.5 seconds here that we're doing. Do a new view. Oh, we got plenty of stars in here. Let's grab one. Let's grab several. There we go. Okay, guiding has begun. So now we'll come in here and we're going to do a 25-second photo here. All right, and we're only at 200, so I'm going to go to 250. All right, gain. All right, and with 250 gain, you can see this nebula even easier. But now we're going to start doing our guided stack here. So over here in the other telescope, we can see the first result of our focus run. It's should be finishing up, and I don't see it finding a guide star. So, I mean a focus, so I have to figure out why it did that. Or if I just get to the bottom of the curve here. And you're right about there. I think that's good. Sometimes it works, sometimes it doesn't. Okay. All right, so now what we'll do is we'll do a 20-second or 25-second photo of the Crab Nebula, and I'll show you what that looks like. So we're gonna back out of that in the two of them. All right, so we're back out of that and start up our live stack. That's the previous one we were in. I'm gonna clear that. We've already saved that. And now come back to see what we've got in our other one, in the Benson view. Oh, look at that. We're gonna have to probably, oh, that's pretty good. So first things first, look at that thing. We're gonna color correct it. All right, and we're gonna adjust our settings here. And I'll show you something interesting when we pull this near the top of the curve and then move this down a little bit. Okay. Now you can see right there, this star right there that you're seeing. There's actually two stars that are very close. That's actually the Crab Pulsar. It's a star that has hot spots on it, and it's spinning rapidly. In fact, it's spinning 33 times per second, and it's a star the size of Manhattan Island. And it's spinning very, very rapidly, and from thousands of light years away, we can see it really bright in there. And the reason is because of the fact that this star is a very, very bright neutron star with these hot spots, and as it flashes us as those hot spots pass by us in space like a lighthouse beacon. There's probably two. So it's doing 33 times per second. Incredible. And this is something that is causing it to look like this beautiful object. Now, one thing I'm going to do, now that I've started doing this, is I'm going to get out of it, now that I've teased you with it, and I'm going to just go back to this mode. I'm going to refocus, because we need to refocus the telescope. Okay, so we'll do that. Okay. Ooh, that's better. All right. Oh, yes. Let's stop this. It'll come back in a minute. Okay, let's focus this guy and let it do its thing. All right. So we're going to focus it. And it'll focus nicely in just a little bit. So back here now, in this other one, look at this. Let's color correct and you'll get a nice black sky. Look at how beautiful that is. So there's a supernova. Now, I showed you the star in the center of it. And you look here, and the star is still there, but it looks markedly blue, which is nice. That blue is because it's a neutron star, all right? And so the blue neutron star shows up nicely, but you see the filaments are not really as well defined. That's because the telescope, being a wide-angle telescope, it doesn't have the ability to see all the subtle details that the other one can. And that is, of course, this telescope over here. Right now, once we get our focus here, we'll be able to get back into the acquisition of the image. But you need patience with astronomy. So we'll wait for the focus to occur. We're sampling all these stars, trying to find a focus. Should find a focus over here. So we're going to wait and see. Interesting. Yeah, that's interesting how it's doing that. That's all right. We can figure it out. It tends to work very well, but there's times when, for whatever reason, it doesn't, and I can't explain why. This is close. I'm going to reset. And I'm going to move us in the positive direction. And see which way it goes. Okay. We'll go negative. Negative one more time. All right, that's going to be close. And in the interest of time, let me just zoom in on these. Yeah, that looks like it may be pretty good. All right, so now what we'll do is we'll try this again. And we'll do this as a 30-second shot now. And we'll get rid of this guy and get rid of our autofocus curves. All right, so now we can go back into our live stack and we'll bring that in. So where are we over here? We are looking here. You can see it at this level. We've got 13 images saved in here. And 13 images stacked, I mean. All right, and that's nice and dark. Beautiful background there. And we can pull this up to pull out any little details around the edges. You can see some, along with some noise. Okay, but again, this is the wide field scope, so the field of view is really this. Okay, look at that. That's how small that is. But how big is it in the other scope? Well, in the other scope, it's this big. All right, and you can see how much different it looks. Right from the very start, you can see more filaments in here just automatically. And if we adjust, even though there's only 2 frames captured here so far, we can bring this down like this, bring the dark level down, make an adjustment to the color correction, and then pull this down just to kind of soften things. You can already see a lot more details and more stars inside this nebula than you could with the other one. So again, this is the Crab Nebula. This is what it looks like. This is an exploding supernova. It's the star exploded in 1054 AD, but the Crab Nebula is several thousand light years away. So it happened several thousand years ago. And then we saw it 1,000 years ago, roughly. And so bottom line is that this is moving outward. And over the course of 100 years, it's been studied. And we've watched it. And over time, you actually watch it go from this to this, we actually visually see it expanding over time. But it's moving light years out into space, so it's taking time to move out there. Space is vast, you know, it really is. So that's why it matters so much that we pay attention to the time scales of the universe. You know. Okay, so I'm trying to look and make sure if there's any questions you guys have, I want to try and get to them. James Dugan, yeah, don't forget to hit the like button. Yeah, please do. Give me a like on this, will you? I mean, 2 observatories for the price of 1, which is 0. Kind of cool. All right, let's see what we're doing in the other observatory. Okay, this guy here, we are up to 19 shots. You can see right here, right there, 19. Yep. Very nice. Okay, let's look at our system here. Let's check out the guider. That's interesting. Still guiding, but it looks like it's a little bit soft, so I have to figure that out. Sometimes that's helpful, sometimes it's not. In this case, it looks like it's stopped guiding, but that's kind of weird. All right, let me do this again. Oops, my mistake. Yeah. Okay, so I have to manually pick one to guide. I'm kind of I have to go on that. Wow, look at that, instantly off. What happened there? Oh, I know what happened there. We have some wind out there. That's why, and this was delayed. Okay. All right, let's watch this correct. This will not stack if this isn't guiding. I set that in the software here. We can do that. Okay. There we go. We're centered up. And now it should be guiding. See, it says guiding again. Why is it no longer guiding? Yeah, okay, well, I don't know why, but we're going to find out. Let's do this one. Let's try guiding on this one. But look at that, beautiful. I mean, we're still stacking and we're still getting good images. So I'm not going to argue with it right now. But look at the beautiful and delicate streamers you see in here. That is really, really beautiful. That's incredible why it's doing that. Absolutely beautiful. Amazing. I'm loving that. Let's go up to a 2-second exposure. Okay. And now let's select again. What's a guide on that really small one up there? I prefer to guide on this one. Let's try that. you can see this ring of O3, double ionized oxygen. You can see this hydrogen, ionized hydrogen. Now, when we get the spectrograph set up, we'll be able to literally take a slice through this and identify all the elements we see in there, and put them in a beautiful display, so you can see just which is which and how much intensity each one has versus the other. It's very, very cool. What I'd like to use for that is software written by Tom Field of Field Tested Systems. Tom is a fantastic guy, good friend, and that software is called RSpec. Letter R, spec, SPEC. If you're into spectra, that's what you want to get. That's the most incredible tool. Tom's a great guy. Okay, so over here in the Sonoran Desert, we have this going here, and I have to basically tools under tools. Let's see here. Well, it's interesting because we're still guiding, so it's kind of weird. Let me go back to 1 second here and do it again. And see if we grab another star. Right. Okay, so now it's took it upon itself to guide that, and then it goes and it stops. Not sure why, but we should let it try, because it isn't ruining the exposure. But this is pretty though. Let me make sure we're good here. Yeah, there's the neutron star in the middle here. You know, you can see it. Let me show you where I'm looking. Right there. There's a neutron star in the middle. That's beautiful. And what I'm going to do is take this dark level and move it up to darken the background some more. And back out a bit. Very, very striking. This nebula, when I was a young astronomer, I looked at this with a small telescope, a medium-sized telescope, a large telescope, massive refractor, 30 feet long, and it didn't have this much detail in it. You know, one singular exposure with a good camera, and look what you get. Amazing. All right, so what I'm going to do is identify this target. All right, and by identifying it, that's the Crab Nebula, and we're gonna set the target to that. All right, and we'll save it, the annotation, so you have that. If you want it, you get it at skytourlive.org, and then we'll start saving. And so now we can save this, and we save the astronomical file format, fits, and then we save exactly as seen as a PNG file. So you can, again, go get this. Now, the size of that image in our telescope here is that big. So it's really, really large compared to the other telescope. And in the other telescope, it's this big, right? And so we set the target again here, right, by solving for what's nearby. And of course, we have M1, the Crab Nebula. We set the target name, and we'll save the annotation. I like being able to self-identify everything. Okay, and now what we can do is save the 38 shots we've taken here. We have a nice spider web out there. Maybe a black widow, but maybe not. Doesn't look like the right web for a black widow. Usually it's a tangled mess with a black widow. Okay, so here's the Crab Nebula. So we got that, and that's pretty good. So those will be available up on the server without any problem. All right, so now what we're going to do is we're going to go to another object. All right, and from here we're going to come back here toward Orion and make our way over now to a beautiful nebula here that we haven't looked at lately, and that is right down here. It's the Casper, the Friendly Ghost Nebula. So we're going to go there now. You'll see the telescope shift back a little bit here. There it goes. See right there? It's kind of behind me. Okay. And we know we're near the Casper, the Friendly Ghost Nebula when we see these two stars. Where is it going? No, don't go there. Where are you going? How about that? Telescope is doing something stupid. At least it stopped. Okay, we're going to try that again. I probably shouldn't though, huh? So if I tell it to go there... Well, first of all, let me have it go to the west. Right, so it's moving to the west. Okay. I mean, it went there and then it stopped. That was kind of weird, wasn't it? Telescope had a brain freeze. Let's do this. Tell it to go there again. Uh-oh. It's not what I want. Okay, telescope is doing something bad. Alright. Luckily, I could turn it off. Which I did. Alright, well, we'll turn it back on. And when we turn it back on, we'll be able to adjust it, have it find itself, and we should be okay. This mount that the telescope is on, we are changing over. We already have it, and it's going to be on the same kind of mount as we have in this observatory. So it's going to be on one of these mounts right here. And that's the one that's going to be very important for us to use. Okay, so let me come back here. So that mount right there, that white thing, that's what we want to use. We have it already. Oh, look at that. That's really pretty. Wow. I'm going to save that again. The more images we take, the cleaner the image looks. And that's what we want. We want it to look cleaner. Okay, let's come back to here momentarily. And let me just pop out of here and make sure that we're going to work fine. It should get its GPS fix, and once it does... See, I don't have that problem with the other mount, and that's okay. Alright, so that's good. It knows where it was. Okay, so what I'll do is bring the telescope up. It should be done with its brain freeze. And I'll bring us to a spot in the sky where I see enough stars. And then I'm going to tell it, once it stops, I'm going to tell it to figure out where it is. And let me actually look and see where it thinks it is. Yeah, it thinks it's way, way away. So what I'm going to do is this. I'm going to tell it to just give me a solution to what it is, and I'll have to put it in manually. Just plate solve. This should be fairly quick. There's plenty of stars to choose from. Here we are. Alright, so it already knows where it is. And what I'll do next is just take those coordinates and figure out where it says it is, and then I will move the telescope, or put the telescope into that region and sync it right there. Alright, it thinks it's at 8:50:19. Alright, okay. So let's go over here and say 8:50:19. Alright, and then go here, and it thinks it's at 0, which is the celestial equator. 20:49. Alright, and if these numbers change, it means it did it. And it did. Okay. Alright, so now if we tell it to go somewhere, let me first make sure the telescope is back and connected. It's not going to be right, so we're going to disconnect and reconnect. There we go. So then it came in, you saw it fly in over there. Alright, so where are we? I saw it fly in. Where'd it go? Oh, it's over there. It says it's over there. Okay. Well, if it knows that, then it should be able to go to the beehive cluster. So let's see if it does. Well, it's heading in the right direction. Okay, that is not the beehive. So, I can actually... Oh, duh. How stupid. Okay, I forgot to readjust. I had to do a few things, which I didn't do when I restarted my mistake. And I'm going to make it stop that in just a sec. Patience, folks. First of all, we can also go back here and look at what's happening over here. Here we are. Okay. Wow, this is nice. So we got a lot of beautiful images here. Holy cow. All right, we're going to save this again. Let's save exactly a scene. Get out of here. Go back to our low light mode. Okay. And now what we can do, back out just enough to show the whole frame. Here we are. That's too much. We'll come out. Well, that's fine. And now what we'll do is I'm going to come back in here. And let's now go to the Casper the Friendly Ghost Nebula down here. And that's this guy right down here. You notice this red arc. That red arc is an ancient supernova. It's called Barnard's Loop. Alright, so now we're going to go here. And the telescope will move a little bit. You can see it. Okay, and there we are. These are the primary two stars that I was trying to show you with the other telescope. And these are the ones that will actually be the ones that we will be using primarily to move around. So what I'm going to do is move them up in the field a little bit. You can see the glow around them already. Okay. And we're going to go right. We're going to go right about here. One more moving up there. Okay. All right. So let's go get our guide star and start an exposure here. So, first things first, let's get a image and let's grab a guide star. Okay, why didn't it want to do it? All right. We're going to take this guide star and we're guiding on that. Okay. So now what we'll do is a 30-second shot of this, and that's starting right there. You can see down the lower right, you can see that coming in, and we'll live stack it and we'll wait to see what comes in. All right. Oh yeah, look at that. It's starting to come in. All right, we're gonna work on that in just a minute. All right, let's actually, okay, not that. Let me come back over here and let's migrate this out. Okay, and that's good there. So you see these two stars. This is a reflection nebula here. You can see there is some brown in here all throughout this. That's actually the dust in this region. Again, this is all a region near the Orion Molecular Cloud Complex, the OMCC. And again, it's an area where there's plenty of star formation going on. And this dark band here will actually become more apparent here in just a few more exposures. We also have some wind out there, as you can see, just enough to get in the way, but we can probably just raise that a tiny bit and do that. So what I'll do now is I'm going to, we'll just let this absorb a few more. James Dugan says, I'm in the guts of Sydney, so light pollution is the same as you guys. But the Carina Nebula is so huge. Oh yeah, I'm sure it's beautiful. Even the Carina Nebula you should be able to see, right? Even with the bright, you can see a hint of it anyway. I'm looking, James, I'm still looking for a Southern Hemisphere site in Australia. And can we do it? Maybe. Benson was just a hope and a prayer, but look, here it is. Hi, Sherry, how are you? All right. So nice to see you. Okay. I'm in the other scope right now, just setting up some parameters. It looks like we're good. And I'm just gonna let this come in a little more. Look at how it's already getting detail in it. That's beautiful. All right. So now That's beautiful. I'm waiting to see more detail there. Gorgeous, gorgeous nebula. You can see the beginnings of this thing. I'm gonna actually move our scope down there now in just a minute. The other one, because I'm pretty much done getting this locked in again, and I'm just thinking it's great. So we're gonna do this, and we are synchronized. Let me make sure. And yeah, that's Oh, we're good. Okay. Okay, so we're gonna bring this other telescope down to this now so you can see that. You won't right now. I'll show you where I am. While this is coming in, okay, I'm over here, and this is the Praesepe M44, the beehive cluster. And I used it as a location to do a focus and a alignment because of a weirdness that happened before. So we're going to try to go to this our object we're in now in the other scope, the Casper the Friendly Ghost Nebula. So let's get over there now. Yeah, we should be able to see that. I'm trying to do this before it gets too low to the horizon is the problem. Because once it does, we won't be able to see it again until, well, the next time we stream. Okay, let's do this now. Here we go. All right. Now we'll try again. And this telescope should move a little bit. Yeah, it's going to be pretty low. But there it is. Now it shouldn't go anywhere this time. Okay, so you'll notice those two stars are the same two stars we saw in the other scope. So I'm going to bring those up a little higher. All right, let me just do this. Okay, so make sure we got it. Yep. Okay, so I'll bring that up a little higher. And center it up. I'm going to slew to the east a little bit and bring that in. All right, you'll see this is the cloud, and we'll move this over a little more. Okay. So this is good. So what we'll do now is we'll set this to going on our on a 25-second photo. Again, this is the wide field system. All right, and we'll back out and go to our deep sky imaging. That's the crab that we did here. We've already saved it, so we'll clear it. And then while we're waiting for that, let's go back and look at this one. Oh, look at, wow, look at those beautiful stars. Look at this stuff here. It's just so beautiful. Let's go to our histogram and let's see if it can handle a little more pushing here. And it can. Look at that. You can see these beautiful details starting to show up. We can darken the background even more. Oh, look at that. Isn't that beautiful? We have this beautiful nebula here. Oh, this is great. Hey, Michael Hendricks, how are you? All right. Now, again, this is nearly the full field. It's like this. So how big are we looking in the other scope? We're getting a close-up with details of this one, right? But in the other scope, look at that. Now we see the entire region. So we actually have two different scopes for two different purposes. All right. And hopefully soon we'll have three. And it's like, it's a disease. You know, once you get into this, it's a disease. You gotta get more, and then you gotta put them online, and you gotta stream. I'll stream them all at the same time. I'll be out of my mind. Okay. Okay, so let's darken up this background a little bit, like this. And let's bring this down a little bit, just to soften that up, and it'll click in here in just a minute. There we go. I'm going to pull this off. All right, and then we'll let that work for a bit. So the close-up view is right here. We're looking at a close-up view of that. All right. It is literally the opposite side. Again, when we get the field rotator, they'll be aligned with each other perfectly. All right. So it's pretty, and let's see how our guiding is doing. Our guiding is right on the money, so that's great. Excellent. Interesting. We gotta just grab that star again. Interesting how it's lining up in this. I have to learn more about this guiding program. I mean, I've never used it until this telescope. So it's slow to learn. Okay, but as you can see, we're getting good results. Very happy with this. Let's see if we can get a little more detail dragged out of it. Oh yeah, we starting to. Yeah, look at that. Wow, that's really nice. Let's identify and target this. Okay, this is Measure 78, known as the Casper the Friendly Ghost Nebula. So that's the target name. We'll save it with annotation, so you get the image saved like this. Okay. And now we go to the other telescope, and we'll do the same thing. I could just write it in, but I like when it defines it, because then I can actually let you get all these things as well. All right, that'll be the target name. And we'll save the image with the annotations. Excellent. Satellite went through, of course. All right. I'm going to check out there. I know that we have some clouds that are kind of heading our way out there, but I'm hoping that it's not going to interfere with this exposure. And it looks like we have a few, but you know what? We should be okay. I'm not going to quit anything. Oh, look, we have another satellite. Woo, we had two that cross each other. Interesting, when you zoom in on this, you can see that it looks like a dashed line. Know what that is? That is something that's doing this. It's out there and it's rotating like this in space, and this is where we actually see it bright. Then when it goes here, we don't see it. Then it goes here and it's bright again. That's what we see when we see these dashed lines. It's a rotating rocket body, probably a spent stage in a rocket that was used to actually launch something else. Let's do this. Let's make this instantly better. Okay, there we go. So we've reduced the color noise on this. That's beautiful. All right. And again, this is the wide field system, so this is the size of the field. Okay, notice this red. This red is part of the Orion complex over here. And then up here in the upper left, you can't really see it. Let's see if we can see it by over-processing. Yeah, you see red down here. This is very subtle. It's very, very subtle hydrogen ionized cloud. You see more up here. And there's that Barnard's Loop thing I mentioned to you earlier, that old supernova in this region. If we look at Stellarium here, we are actually, you are here. We are here, and here is the loop, right? And then we have part of the Flame Nebula here, and some of the other stuff that's out here, which we actually see in here, right? And you can see red all throughout this region. This is an area that's full of many different kinds of incredible nebular details. See, if we do this, you can see it more. And if I bring this curve right up to black level, get to about, that's a little too far, bring it back a little bit, you'll see it better. Oh, zoom. Zoom. Next we need one to go this way to kind of frame it all in. So this is the Casper the Friendly Ghost. You can see other detail up here. However, in the other scope, we don't see that because it's outside of our view. Okay? But it's kind of neat, isn't it? So we can save this right here. This is 27 images, and we'll save exactly a scene. Nice. And this is kind of low to the horizon now. So we're actually seeing it pretty good for that low to the horizon. All right, so this is showing you more of what's in there. This is over processing. Okay. Neat. All right, so we will leave this guy behind and go back to our low light mode. There it is. And let's now go over to Stellarium and see. It's 12:30 here. I wanted to do one more fun one, and that's going to be this guy right here. This one's a fun one to do. It's nearby. Telescope's already on it. There it is. Now, it's upside down from this perspective to us. But this is a cluster. And let me just do a 15-second shot of this. But before I do that, I'm going to, I'll say, okay, 16 seconds. Let's go here and reacquire an image field. And let's grab stars if we can. Very good. And we'll just guide on those. Okay. All right. So we're guiding away. And now we're going to do our 25-second shot. And we'll come out of low light mode here and just go into our live stack so you can see this. Hi, Fantasy. What's up? So we're going to go there. And let's go now over to here. And we'll save this as well. Save it exactly as seen. And now what we can do, that's going to be a real pretty one as well. And now what we'll do is we'll come back to our 1 second shot in this telescope as well. It's our low light mode. There it is. And then we're going to go to the same thing here. And that is going to put us... it's up here. Come on. I can't believe I can't find it. I just found it in the other one. This is the 37. I don't know why I can't find that. Let me go back to the other one. Just grab it. Okay. So in this other one, if we do the target name here, we should be able to find it. There it is. Oh, it's the LE, that's why. It's known as the LE cluster, but we call it the 37 cluster. But you'll get an idea why it's called the LE cluster, because here we are looking at it from upside down, and it looks like an L and an E. Okay, it doesn't look like the 37. To see it as a 37, you flip it upside down. So in this telescope, it truly does look like the LE cluster. And in this other scope, when we come over here and we look for it over here, there's Betelgeuse, so it's going to be up here, right there. Okay, we go there now, and the telescope's going to raise up high. All right, and we'll see the cluster pop into view. There it is. But from this perspective, it looks like a 37. See, what happens is optical systems will show you the sky very differently. It depends. Some are reversed and upside down, and our telescope does do some changing of the image, and we want to actually make sure that we can see the image. But here we're going to see two different things. We're going to see it as a 37 in this view, and this is the wide field view of our telescope with the wide view. Okay, and there we go. So let's do a 20-second shot of this, because we don't need that much with this guy, because it's a beautiful bright cluster. And then we'll go into our deep sky mode. And the last image we took will be in there. That's that beautiful M78, Casper the Friendly Ghost Nebula. And when it's done, it'll just overwrite this. It should anyway. So we'll wait it out and see what happens. And there it is. The 37 cluster. And we're going to color correct, and then we're going to do this. So you can see blue, I'm sorry, you can see red nebula in here. This is this red diffuse hydrogen all throughout this region that is actually being excited by hot stars in the area. In the other view, the other telescope, we have this close-up view of the 37, and we're going to take, first of all, we're going to take this value and bring it just to the left. So now we can see a little bit more detail here. We'll color correct again, get our curves lined up, and now you can see the LE from this perspective. Notice some stars are red in here. That means that they've gone to red giant stage and used up all their hydrogen and stopped making hydrogen into helium, and therefore they've gone to the red giant stage, and in time they will go probably to white dwarfs. Yeah. Yeah, Izabela says, oh, the 37 cluster, the little joke of the universe. Yeah, it is. But see, Izabela, it's an LE. It's an LE. Here's the E. Okay, LE. So, at least here anyway, that's what it looks like, right? So, we actually have, the L. Okay, and then we have the E. That's the LE cluster. So that's the way that one works. But it's beautiful, and we have a nice close-up view of it, and I just think that's gorgeous. Look at that. Again, and the most important thing to understand is that there's red giants in here now. And it's showing you that this cluster has evolved. It's been around long enough for its stars to run through their hydrogen and start going into red giant stage. So it's pretty cool. Alright, so let's look at the other one. Here you see the 37 cluster, because we're now flipped the other way with this telescope. And we can probably take this and move it a little bit in. Okay, and what I'll do now is I'm going to identify this and set it to the target, the LE cluster. Okay, and then I'll save it with annotations, and then I will take us out of here and let that continue to come in for a minute as we go back to the other view, which is the close-up view where the colors are more obvious, and we'll identify it here as well, which it already has been, and we'll set its target name, save it with annotations so you can actually get this. Yeah. Okay, and then we'll save it, and then save it exactly as seen. Izabela, make a note that the LE cluster, or the 37 cluster, I had saved it in the wrong directory, and I just corrected that. So I'll make that correction on the server. So if you're gonna put those in the app, don't do that first one I did, because that's in the wrong directory. This one is the better one to do. Hopefully that made sense. There it is, beautiful. 28 shots, nicely done. Really good. All right. So that's gonna wrap it up for tonight. We have a 37 and the LE. Okay, 2 different telescopes, 2 different locations. This telescope is in Benson on the plateau, where we have marginally darker skies than here in the Sonoran Desert. Here we're at 1,600 foot elevation, and here we're at 3,600 foot elevation. So we're literally another 2,000 feet higher, and it actually shows in the quality of the night sky. I really want to attach to this telescope, I really want to attach a camera system, that'll show you a wide view of the whole night sky, so you can see what I talk about when I talk about Milky Way shots that are just like, we could take pictures of the Milky Way that'll just make you cry. It's just gorgeous. So I'm going to put a wide angle camera on here that will actually take pictures of the whole night sky like that. Maybe with like a mild telephoto. And that'll be yet another camera. And then we wanted to get the spectrograph as well to go on the telescope. But we're going to make sure that all happens. All right. So guys, I want to thank you all for coming tonight. I hope you enjoyed it. Make sure you go to skytourlive.org. Also, consider donating to our Patreon. You can join us. You can go to our skytourlive.org and donate to us if you want. You can go to our Patreon and subscribe and join us for the Patreon. We'd love to have you. You can go to the SkyTour shop and buy images like we've taken tonight that have been put on many different articles of clothing, office stuff, clocks, shoes. We have Horsehead Nebula sneakers out there. Okay, and they're beautiful. I everything that we have out there, we've purchased and looked at. You know, because I won't have any crap going out the door, and so that's pretty cool. So everything I've have out there, I've approved, and not some things are crappy, and some things, like there were some magnets that we bought, really flimsy, barely worked. They're out the door. Forget it. You know. Anyway, I hope you guys have a good evening, and it was so nice to see you here. Thank you for joining me tonight. Make sure you hit the thumbs up. Make sure you like us. You know, where else can you get free astronomy? From 2 observatories, no less. Soon to be maybe 3 when we get the solar telescope running. Okay, out here. Anyway, you folks have a good night, and we'll see you on the next stream. So good night, everybody. And Daryl had the night off, so for him, I'll say good night, everybody, because that's what he would say. All right, folks. See you later.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours